All right, so polynomial models. We're looking at section 7.2. And the first word you need to write down here is figure it. Okay, figure it numbers are numbers of points in a pattern sequence of familiar geometric shapes. So notice we're starting with a 1 point. Then we're adding 2 more points to it. And notice it's staying in which shape? Triangle. Thus they're called triangular numbers. Dun, dun, dun. Okay. This one is tetrahedral because it has 4. Okay? But that's like, it's like a pyramid with a triangle base. Okay? All right. So the reason why we're looking at these is this is what our lesson's based on. Polynomial difference theorem. I'm going to tell you what that is in just a minute because first of all, I want you to notice something. I want you to go through this and tell me what is the difference between 2 and 9? 7. Yes, they are all constant at this point. Okay? On this one, what is the difference between here and here? 0, 2, 4, 6, 8, 10. Now, they're not at a constant difference yet, so we need to find where that constant difference is. We'll do it again. 2, 2. Oh, we finally, I think, hit our constant difference. Okay? Now, when you get to a set of constant differences, here we did it at the first set. So that means this is to the first degree polynomial. So what kind of a polynomial is this if it's at the first degree? Yeah, so it's a linear. This one's linear. Okay? This one's to the what degree? Second, because we had to do this twice. So what kind of polynomial is this? Quadratic. Good. Because it's x to the second. The first one is an x to the first. Okay? So basically, back to our definition here, it says the function with the equation y equals f of x is a polynomial function of degree n, if and only if, for all set of x values that are consecutive terms of arithmetic sequence, the nth differences corresponding are equal and non-zero. So in other words, once you get to the point where all the differences are the same, that's the degree of the polynomial you have. So, okay? All right. Let's look at example 1a. It says, consider the tetrahedral numbers 1, 4, 10, 20, 35, and 56. So what you're going to do is you're going to write them out. And it says what degree of polynomial this could be. So what do I need to do? Find the differences. So this is going to be 3, 6, 10, 15, 21. Okay, and then we do it again.
It's third.
It's gonna be 4.
It's third.
Oh, right, I forgot.
So this was our first degree here, right? This is our second. So therefore this one is third degree polynomial.
Wait, you don't count the first one?
No, this was the original.
Oh, okay.
So you don't count those.
What is the third one? Is it x to the third, which is?
Yes, it would be an x to the third level. It's a cubic. Okay? No, this is not bad. Okay. Turn the page. Oh, I got a couple more things we gotta go through. We're not done. Okay, so now, I want you guys to do this right now. Do the same thing with this one and tell me what degree do you get to. Okay? So I'm going to just pause this. I'm going to give you a second to figure it out. And then I'm going to show you, when we're done with this, how to find the equation for these polynomials. Okay, so what degree did you guys get? I got third degree. Okay? So
Good afternoon, and please excuse this interruption.